Hello there, children. Today we are going to work on section 7.4, which is inverse functions. This educational experience is brought to you by your inspector of inverses. That would be me. Alright, so let's take a peek here. So, just a review from Algebra 1. A relation, and earlier this year, a relation is mapping input values onto output values. An inverse relation is actually going in reverse, where the output values get mapped back onto the input values. So for instance here, if I had a relation where I input a 1 and I got back a 5. If I input a 2, I got back a 6. Input a 3, get back a 7. If I input a 4, I get back an 8. The inverse would be now if I put in a 5, I get back a 1. It flips them around, so to speak, for our purposes. So that's really, really, really important. So a relation is just whatever it is. The inverse, all it does is switch your input and output locations. Alright, moving forward. So, for us to find an inverse, what we are going to do, equation-wise, you simply switch the x and the y values and solve for y again. What the heck does that look like? So, here's my original function, 3x plus 5. What the heck is my inverse going to be? What's the inverse of y equals 3x plus 5? First order of business is to switch x and y. Literally, wherever you see the letter X, you are going to write the letter Y. Wherever you see the letter Y, you write the letter X. Then all you do is solve now for Y. Get Y by itself. How do I do that? Subtract 5! Very good, imaginary voice in my head. I subtract 5, and then what? Divide by 3! Nice job. Here's my inverse. Now notice here, I wrote it two different ways. What is the difference? Distribution of 3. Very good, other imaginary voice in my head. So, all I did to solve here, I switch x and y. Solve for y by subtracting 5 and dividing both sides by 3. Now, this is fine. Or, I could take x divided by 3, get 1/3 x, negative 5 divided by 3. Negative 5 over 3. Both of those are fine. Moving on. Now, let's look at two of these problems here. I have the original problem as y equals, in this case, x plus 4 over 8, and y equals negative 8x plus 12. Try these on your own. I'll give you a few minutes here. Give them a whirl. So, let's look here. Here is how you do these. First off, in both problems, you switch x and y. Instead of writing a y, write an x. Instead of writing an x, write a y. Now, in the problem on the left here, how do I get y by itself? Subtract 8. I get x minus 8 equals y over 4. How to get y by itself? Multiply by 4. 4 times x, 4x. 4 times negative 8, negative 32. Okay, over here, I switch x and y. How do I solve for y? Subtract both sides by 12. Then divide both sides by negative 8. This is fine, what I did right here. X minus 12 divided by negative 8. Or, if you wanted to get particularly fancy, take x divided by negative 8. Negative 1/8 x. Negative 12 divided by negative 8, which is a positive 3/2. Both of these are acceptable. So again, the reason it's an inverse is I'm switching around what I'm doing. I am essentially, instead of putting in the x first, I want to put in a y. How does that look? I have to switch their positions to start. Alright, moving on. Now, just some terminology for us. If the original function and the inverse relation that I say happen to be functions, we say that they are both inverse functions. And you're like, what does that mean? That means if I find a relationship and I find an inverse, and both of those functions pass the vertical line test, they are inverse functions. You're like, well, is it not an inverse function? Anytime I deal with squares or things like that, they won't give me inverse functions. But we'll talk about that much, much later. Don't you worry. But for right now, if two things are inverse relations, they are also going to be inverse functions. Okay. Now you're probably wondering, how does this stuff relate to the stuff we've been doing already? Well, functions f and g are going to be inverses of one another, provided that f of g of x equals x, and g of f of x equals x. Remember we talked about last section that the composition of functions, which is what these two things happen to be, that they don't necessarily have to equal each other, but when they do, something special happens. This is that something special. So anytime you put in an x, you get back an x. Put in an x, get back an x. They are inverses, and just so you're clear, we denote inverses as f to the negative first power. This is read as f inverse. Now, you don't have to flip this around as a fraction. This is common notation as you're going forward in math. When you talk about an inverse function, and we have the function f of x, its inverse will be denoted as f to the negative first here. Now, if you just want to write out the inverse is blank here, that's fine. But no, as you move further along in your mathematical careers, this will be noticed as inverse notation because it's, shockingly enough, an inverse. Okay, moving on. So verifying two things are inverses. So I'm going to give you a function here. F of x equals negative 3x plus 6. And I'm claiming something to be an inverse, where it's negative 1/3 x plus 2. There are two different ways to do this. First off, here's the first way, where you go, okay, I'm going to put the f function into the other function, and then flip the order around. So, what do I do here? What is the f of x function? Negative 3x plus 6. Everywhere in the inverse function, I see letter x, which is this one right here. I replace it with this. 3x minus 6. Negative 1/3 times negative 3x plus 6. Negative 1/3 times negative 3, 1. Negative 1/3 times a positive 6, it's a negative 2. Negative 2 plus 2 goes away. I'm left with x, which is good. That's what I wanted. Now, the other way to do this, then you have to do is go, okay, now, everywhere in the top function that I saw the letter x, I am going to replace it with what I think my inverse is going to be. Negative 3 times negative 1/3 x, x. Negative 3 times 2, negative 6. Negative 6 plus 6, x. Both of these were equaled. That makes me happy. Terrible smiley face, I know. Now, if you're like, Mr. Faust, that seems terrible. How do I verify two things are inverses, and I don't want to do composition of functions? Well, let's go back to our original rule here. Pick one of these. It doesn't matter which one. I'm going to go with the top one. Why? Because, very good imaginary voice in my head, I picked this top function. Now, as you recall, f of x is the same thing as saying y. So I have y equals negative 3x plus 6. Now, how do I find an inverse? Because I'm claiming you that this function right here, that negative 1/3 x plus 2 is an inverse. Here's what you do. Ready? Simply switch x and y of the other function and solve for y. Now you're like, why do I do that? Well, here's the thing. If I am claiming two things are to be inverses, after I switch x and y here, I should be able to find the inverse of the top function. So like here, subtract 6. And it should match the bottom one. Why? Because they were claiming them to be inverses. So I have x minus 6 equals negative 3y. And what do? I divide both by negative 3. Now, when I divide by negative 3, you're like, Mr. Faust, this thing I found, that x minus 6 over negative 3, that doesn't match this. So they can't be inverses, right? Not quite. Watch. What's x divided by negative 3? Well, that's negative 1/3 x. What's negative 6 divided by negative 3? That's a positive 2. Now, look. This function right here matches this function down here. So are they inverses? Yes, because what happened was I took one of the functions, found its inverse, and it matches the other one. So anytime you're asked to verify inverses, simply pick a function, find its inverse, and see if it matches the other function that they give you. So now you are ready to go henceforth and try some work on these about finding inverses. Go henceforth and do.